Welcome back, classes. We are continuing our unit on polygons, and today we're going to talk about rhombuses, rectangles, and squares. Yay! A quick overview, that chart once again. What are we talking about, y'all? We're talking about quadrilaterals. So we've been going over quadrilaterals. We talked about parallelograms, which is a certain type of quadrilateral. And today we're going to start talking about rhombuses, rectangles, and squares, which are certain types of parallelograms. And so we have all these different types, right? And you can see here in the chart, the most specific thing we have is a square. But anyway, they're all types of parallelograms. We're going to jump right into that. So the lesson on rhombuses, rectangles, and squares, we're going to discuss classifying special parallelograms, which is what these are. We're going to find angle measures, which means algebra, and finding diagonal lengths, which means more algebra. But let's jump into some notes. Yeah. All right. So we have a note on the rhombus, or how it's spelled, the rhombus. So we have the rhombus, the rhombus. If a parallelogram is a rhombus, then its diagonals are perpendicular. Now, this is not the only time we're going to see this, but that's a neat thing. So what is a rhombus? A rhombus is any quadrilateral that has four congruent sides. That is a rhombus. Any quadrilateral that has four congruent sides. Now, there's something cool about the rhombus, which is here. The diagonals are perpendicular. They intersect each other at 90-degree angles. And it's not the only thing. We'll talk about that later. Something else that's cool about a rhombus, when you talk about rhombuses and diagonals, each diagonal bisects a pair of opposite angles. So if you have a rhombus, the diagonals start bisecting the opposite angles. Okay, so the opposite angles, and then you realize, holy cow, there's a whole lot of congruency that's going on here. Okay, but that's the note, and we're going to dive into that a little bit later. But that's some neat things about rhombuses and diagonals. Okay, diagonals intersect at perpendiculars, and they bisect the opposite angles. So what's going on here? I'll talk about the shapes in general, but there's another thing about diagonals, and it's dealing with rectangles. Rectangles have some neat principles for diagonals as well. Now, we already know that the diagonals bisect each other. How do we know that? We know that because these are all types of parallelograms. Remember, in parallelograms, diagonals bisect each other. But if we're dealing with a rectangle, which means four right angles, okay, a rectangle, four right angles, then not only do the diagonals bisect each other, the diagonals are congruent. Okay, so that's a neat thing about rectangles, neat note. So here is basically the special parallelograms. So we have our special parallelograms in a nutshell. We have the rhombus. Any parallelogram at all, as long as it has four congruent sides, we have a rhombus. That's it. Don't worry about what it looks like, how it's shaped, what the angles are. If there are four congruent sides, dude, it's a rhombus. That's it. Now, what if we have a rectangle? It's any parallelogram with four right angles. It doesn't matter what the sides are, as long as it's four 90-degree angles, right? Four 90-degree angles, we got a rectangle. Blam! That's the definition of a rectangle. And then my favorite and yours, the square. The square is this awesome thing because it has four congruent sides and four right angles. So the square is awesome because the square is a rhombus and the square is a rectangle. Yeah, square. Squares are so cool. Anyway, those are the notes. So let's do some work. Let's see some examples of work. Yeah. All right. So we have this little diagram here. I don't know how clear it's going to show up on the video, but there's a diagram here, and what we're going to do is classify this thing. A, B, C, D. I read it this way on purpose. You'll see why in a second. A, B, C, D. A, B, C, D. Is it a rhombus, a rectangle, or a square? And let's explain. Now, don't judge anything by looks. So you want a life lesson? Here, I typed it out. This is a life lesson. Don't judge things by looks. Okay? It's a life lesson. So it not only applies to how we treat one another as human beings, it applies to geometry. So you don't judge things by how they look. We have to prove stuff, right? Prove merit. Prove what's going on. So is this thing it looks like a rectangle, right? Right, well, we have something interesting that's happening here. We have a 90-degree angle in this corner here. Angle B is a 90-degree angle. That's given. Now, is it a rhombus, a rectangle, or a square? How do we know? Well, here's what's interesting. I read this as ABCD, and I read this not fully accurately. This little symbol right here tells us everything we need to know. That little symbol says parallelogram. Is parallelogram ABCD a rhombus, a rectangle, or a square? Now, the fact that we have a parallelogram, holy cow, do things unlock. Because what do we know about parallelograms? We have a whole list of things that we know about parallelograms. We know that opposite sides are congruent. We know that opposite angles are congruent. We know that consecutive angles are supplementary. And we know that that the diagonals bisect each other. We know all this thing about parallelograms, old stuff, that we can apply here. So this is a parallelogram. Now, what does that mean? That means if this angle here is 90, we know some things. The opposite angle is also 90. Bam. And not only that, we also know the consecutive angles are supplementary. And if consecutive angles are supplementary, and this angle is 90, guess what? This angle is also 90, another 90-degree angle. And then guess what? This angle is also 90. So because it's a parallelogram, we now know all this stuff. So what do we have? We have 4 90-degree angles. That's all we know. We don't know any lengths. We don't know anything about congruent. We just know that we have 4 90-degree angles. So guess what we have? We have a rectangle. So we better know our parallelograms. We have 4 90-degree angles, okay, 4 right angles. We have a rectangle. And so that's how we classify it. And what gives it away? The fact that that little symbol says parallelogram gives the whole thing away. Okay? So that's how that works. Pretty cool, huh? Let's do another one. So here's another example, similar picture, right? But now we're looking at, is EFGH. EFGH. Is that a rhombus, a rectangle, or a square? And let's explain. So I don't know if this is going to show up well, but EFGH. We have a tick mark here and a tick mark here. What else do we know? Well, let's read this again. I said EFGH, but dude, parallelogram, EFGH. That gives us a whole bunch of information. Because what do we know about parallelograms? We know opposite sides are congruent. So if EF has 1 tick, then HG has 1 tick. And if HE has 1 tick, then GF has 1 tick. Guess what? All 4 sides are congruent. So, parallelogram, we have 4 congruent sides. 4 congruent sides. What has 4 congruent sides? That's all we know. We don't know anything about the angles. We don't know anything about the angles. We just know 4 congruent sides. So what is that? That's our rhombus. Pretty cool, huh? So you got to know your vocab and know how to apply it and know how to think clearly, but mostly don't overlook the things, right? Don't overlook simple things. All right, so let's do some more examples of stuff that's going to go on. So here, we're going to do some algebra. We're going to find some angle measures. So what are the measures of the numbered angles in rhombus ABCD? Now, this went ahead and gave us a whole bunch of information by calling it rhombus. Not only are all 4 sides congruent, right? Boom, 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 boom. Not only are all 4 sides congruent, we also know that the diagonals bisect the opposite angles. Okay, so now we know the diagonals bisect the opposite angles. So if this is 58 here, because it's a rhombus, this is 58 here. And because we know that, guess what's going on? We know, since it's a rhombus, which is a parallelogram, which means that BC and AD are parallel, that means we have alternate interior angles that are congruent, right? So that means angle 3 is 58. And that means angle 2 is 58, right? Holy cow. So we now know angle 3 and angle 2 are both 58. Let's go ahead and write that down. Angle 2 is 58. Angle 3 is 58. Some neat information that's happening here. Now there's more. Just wait, there's more. We can find angle 4 in a few different ways, but we'll figure that out in a second. What about angle 1? Any thoughts on what's happening with angle 1? Do you remember the note on the rhombus? Diagonals are perpendicular. Ah, intersect at 90-degree angles. Yeah, buddy. So that means angle 1 is a 90-degree angle. So if we have angle 1 as 90 degrees, and we have angle 2 and angle 3 is 58, well, then what is going to be angle 4? A few different ways to do this. We can talk about supplementary consecutive angles and split that. We can talk about, well, I'll do it this way. We can talk about the interior angles of a triangle. So angle 4 is, along with angle 3 and angle 1, inside of a triangle, interior angles. Angle 1 is 90. Angle 3 is 58. If we add them, we're going to get 148. So these two are 148. That means angle 4 is what's left after we take 148 from 180. Okay, so that's what we're going to have left. So we do some subtraction, and we're going to get 32. So angle 4 is 32 degrees. Okay, so we're able to unlock all of those angles in this rhombus because we know those notes. So that's what that example will look like. Some fun stuff about a rhombus. More examples. Yeah. So now we're going to figure out what are the numbered angles in rhombus P, Q, R, S. And once again, we got to read carefully. This says rhombus, so it's giving us a whole bunch of information. Now, this one gets kind of tricky here because with these 4, 1, 2, 3, 4, we know that 1 and 2 are congruent and 3 and 4 are congruent to each other. But what's interesting, and we talked about this briefly, is if this is a parallelogram, right? These two are parallel. That means we have angle 3 and angle 2 congruent to each other because of alternate interior angles. But check this out. If this is a parallelogram, that means we have both pairs of opposite sides parallel. So check this out. What's going to happen here? Watch. If I turn it this way because I'm not letting gravity mess with me, guess what else I have? Alternate interior angles. So 1 and 4 are congruent to each other as well. So isn't that neat? That means for the rhombus, 1, 2, 3, 4, when we have a diagonal, we now have 4 congruent angles, right? That's kind of cool. But you might be thinking, Mr. Katz, what does that have to do with anything? That has to do with this. So we have our given angle at 104. Okay, so here's our 104. It is a parallelogram, so therefore it is supplementary to the angle down here, supplementary to angle P. So that means angle P, this corner angle, is going to be 180 minus 104, okay, which will leave us with 76. So angle P in itself, that whole angle is 76, right? Because we have to remember consecutive angles are supplementary in parallelograms because a rhombus is a parallelogram. All the things about parallelograms apply to the rhombus as well. We can't overlook that. Don't forget. Anywho, 76 is the whole thing, but it's split in half. So if we have 76, divide that by 2, we're going to have 38. So that means each one of these angles is 38. So look how easy it's going to be to fill in all this stuff. 38, 38, 38, 38, all 38. Okay? So we have to remember some stuff about the rhombus. This is where the notes come in. Cool? Cool. More examples. Woo! All right. So now we're going to find a diagonal length. This work on this. More algebra. So here it says, in rectangle RSBF. Oh boy, did we just get some information right there. Holy cow. The word rectangle gives us so much info. If we remember, the rectangle is a parallelogram, right? The rectangle is a parallelogram, right? But it also has, because it has 4 90-degree angles, we also know that parallelograms have congruent diagonals. Each diagonal is congruent. Not only does it bisect each other, it is congruent. So we've got to know some stuff, right? So it says rectangle RSBF. Now we have a lot of information. It says SF is 2x plus 15. SF, the whole thing, 2x plus 15. And then RB, 5x minus 12. RB, 5x minus 12. What is the length of a diagonal? So we got to know some stuff. Check it out. Remember, rectangles have congruent diagonals. We now have an equation, right? Congruent means we have an equation. So f excuse me, SF, 2x plus 15 is actually equal to 5x minus 12. That's what the rectangle means. It means that. And now what we can do is a whole bunch of algebra. So check this out. I'm going to not show work. You show work. You do it. I'm going to not show work. I'm going to do some stuff. Let's see if you can figure out what just happened. Did you see the work I showed or the work that I didn't show? I subtracted 2x on both sides. And I'm going to do it again without showing work. Hopefully you see the work I didn't show. I added 12 on both sides. And then I'll do something else. Let's see if you notice what happened. I have divided both sides by 3. So I've solved my equation for x. I know that x is equal to 9. But why did I circle that? That's not the question. The question is, what is the length of the diagonal? Okay, so don't circle yet. Not yet. Read the question. The length of one of the diagonals. Okay, so we know x is 9. Well, now we know 2x plus 15, but x is 9. So 2 times 9 plus 15. That's 18, and 15, that would be 33. Now, before we check, let's make sure, does it work out here as well? Right, so we have 5 times 9 minus 12. 5 times 9 is 45. What's 45 minus 12? 33. All right, so now we know. We know for sure. So x is 9. Don't circle it yet because we have to answer the question. It's 33 units. Okay, now we know the length of a diagonal in this case is 33 units. Why? Because rectangles have congruent diagonals. Cool? Cool. I think the bell's going to ring soon. Hang in. We're almost done. Now, we're going to find some more diagonal length. Here's another example. ln is 4x minus 17. ln, 4x minus 17. mo, 2x plus 13. mo, 2x plus 13. What is going on with this letter p in the middle? So we have ln here, right? And then mo here. What's going on with that letter p? We don't need it. It's a distractor, right? The question is, what are the lengths of the diagonals of rectangle? Rectangle. Again, congruent diagonals. So now we know. Diagonals are now congruent. We now have an equation. The whole diagonal, 4x minus 17, is equal to the whole diagonal, 2x plus 13. And again, we're asking the length of the diagonal. Not just solve for x. We're finding the entire length. So let's do it. Same thing as before. The first thing I'm going to do is subtract 2x from both sides. And then I'm not going to show my work. You show my work. And then I'm going to add 17 to both sides. And then you show my work. I'm going to divide by 2. So now I know that x is 15. Now that I know that x is 15, I can start plugging stuff in. Okay, so if x is 15, I have in the fourth thing, 4x minus 17. So we have 60 minus 17, which is 43. Let's make sure that's the same on both sides. I also have 2x plus 13. So 2 times 15, 30 plus 3, 43. I know it works. 43 units. Okay, so you want to plug in and make sure we know we have congruent diagonals for the rectangle. All right? All right. Next thing, we're going to jump into the quick quiz. So here's the question now, right? Here's the question. Is parallelogram, dang, there's that word, parallelogram, we have just got a whole bunch of information here. Is it a rhombus, a rectangle, or a square? And let's explain. So we have here 7.5 centimeters, 7.5 centimeters. This thing is a parallelogram. What does that mean? That means opposite sides are congruent. That means this side is 7.5 from here, and this side is 7.5 from here. So guess what we have? We have 4 congruent sides. What do we know about 4 congruent sides? Rhombus. We know we have a rhombus. Now, look at this tricky. Is it A, a rhombus, or B, a rhombus? We have to read. A says rhombus because opposite sides of a parallelogram are congruent, so the figure has 4 right angles. Wait, what? Sides and angles is not A. Be careful. Read carefully. How about B, rhombus? The opposite sides of a parallelogram are congruent, so the figure has 4 congruent sides. That's the stuff. So it's answer to question B. We've got to be careful with these stupid questions. And I don't mind calling it stupid. It's what it is. They're stupid. So you got to be careful with stupid questions. Know your rhombus. Last example. Here we go again. Once again, parallelogram, KLMN. Man, parallelogram. Now, it's giving us this. The measure of angle KLN is 63. KLN, that's 63. We now know a whole bunch of stuff. What is the measure of MNL? MNL. So here's the question. Guess what we know? We now know that if this is 63, this is 63. How do we know? Because alternate interior angles are congruent when lines are parallel. And we also know that diagonals bisect the rhombus. Okay? Pretty cool, huh? All right, last question. This is a good thinker one. You were asked to draw an equiangular rhombus. Rhombus for congruent sides. An equilateral rectangle. Rectangle for right angles. And a parallelogram with 4 right angles. That's a rectangle. Will all 3 figures be squares? Huh. Well, that's interesting. Is an equiangular rhombus a square? Well, a rhombus has 4 congruent sides. But if it's equiangular, that means all 4 congruent angles as well. So guess what? That's 90 degrees each. 90 each. Therefore, this one is definitely a square. We got a square here, no doubt. Square. How about an equilateral rectangle? Rectangle, 4 right angles. Equilateral means 4 congruent sides. So in this case, we have congruent sides, congruent angles. That's a square, brah. So this is also a square. What about the last one? Parallelogram with 4 right angles. This says nothing about the length of a side. No side information. Okay, there is no side info. So we can't make a determination. We can't tell if that's a square. Okay, so let's figure it out. The question is, will all 3 angles be squares? No. We already know that. No. No, because a parallelogram with 4 right angles is a rectangle, true, but not necessarily a square, true. Okay? We already established that the rhombus is a square, and we've established that the rectangle is a square, but we have not established that this parallelogram, that end, is a square, because we can't. Okay, so that's a good thinker question. And that's it on rhombuses, rectangles, and squares for now. In the next lesson, we'll talk more about that stuff, but it'll get super exciting. Just remember, this is what we're figuring out, right? All these things that make special parallelograms special. I'm out.